Welcome to the Advisory Science channel. Remember learning about light in Year 3? Light allows us to see the world around us. Light travels incredibly fast. This speed lets us see things instantly. Without light speed, it'd be like watching a laggy video. But thanks to light, we see colours, shapes, and object details. A long time ago, a Greek mathematician named Euclid discovered that light travels in straight lines. We call these straight lines rays. We can see light travelling in straight lines all around us. For example, when sunlight streams through a window, it creates straight beams of light onto the floor. Or, like how a torch lights up toys when it's shone in a dark room. The light rays travel straight from the torch to the toys. Another example where light can clearly be seen travelling in straight lines is using a laser during precise eye surgeries. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. How do we see objects with reflected light? Our world is full of colours, shapes, and objects, but how do we see them? Let's look at some examples. It's all about light reflecting or bouncing of objects into our eyes. Smooth, shiny surfaces like mirrors reflect light clearly, so we can see a clear reflection of ourselves. Rough surfaces like cardboard scatter the light, so the image that we see is blurry. Clear glass lets most of the light pass through it, so we can see objects behind it. Frosted glass only lets some light through, making the objects behind it blurry. Opaque materials like brick and metals block light completely. Black objects absorb almost all light, so no details are visible. And did you know, black holes absorb all the light that enters them? So now you know all about how light interacts with different objects. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. How can we improve reflection? Because light bounces off most surfaces, this lets us see them and even from far away. But sometimes we need extra help to see clearly. Certain types of engineers create special reflective materials. One way to increase reflection is to add mirrored coatings, like on a phone camera. This bounces light straight back for sharp, clear pictures. Another way is to use tiny beads stuck on materials. Each bead acts like a mini mirror. Together, the beads bounce light directly back to the source very strongly. Road signs and bike reflectors use millions of beads to shine bright. Periscopes are special pieces of equipment that have mirrors inside them that are set at an angle. This bends the light and allows us to see around corners, above the water level like in a submarine, or around obstacles. Rear view mirrors are angled so that light from behind the driver is reflected off the mirrors and bounces straight into the driver's eyes. So these are some ways that we can increase the amount of reflection, helping us to see more easily. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. What shapes our shadows? Opaque objects block light from passing through them. The object absorbs and reflects some light, but it stops light reaching behind it. This creates a shadow in the area behind the object that light can't reach. Because light can't bend around an object and can only travel in straight lines, the shadow will match the object's shape. If you move the light source closer to the object, the shadow gets bigger. And this is because the object blocks more of the light source. If you move the light source further away from the object, the shadow gets smaller. And this is because less of the light source is blocked by the object. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. Can we bend light? Now this lesson is slightly more tricky, but we'll break it down so we can understand each part. Light is the fastest thing on our planet. It can travel around the Earth 7 times in just 1 second. As light moves, sometimes it travels from one material to another. When light moves from one material to another, it can change its speed, but it can also change direction. We say that the light is bent. This change in direction, or bending of light, makes things appear differently. For example, a straw in a glass of water appears bent. A coin in a bowl of water looks to have shifted from its actual position. Now, white light is not just one colour. It's a combination of many colours. The colours of the rainbow: red, orange, yellow, green, blue, indigo and violet. Each colour in white light bends by a different amount when it enters a new material. This explains why rainbows form. The light from sunlight actually contains lots of different colours. As this sunlight passes from the air into liquid raindrops, each colour bends a slightly different amount. And this forms the rainbow arc that we see. And soap bubbles show colourful patterns because of this same bending. So now you know that light can bend, and it can change the way we see different objects. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. What are colour filters? We've previously learned that when light hits an object, it can bounce off, pass through, or be absorbed. We've also learned that sunlight is in fact a range of different colours, and when sunlight hits an object, not all of the colours behave in the same way. In opaque objects, some colours are reflected and some are absorbed. The colour of the object that we see depends on which colours are reflected and which are absorbed. So, to give an example of this, when sunlight hits a red flower, the red light is mostly reflected, but the other colours are absorbed. So this makes the flower look red. For yellow objects, yellow light is mostly reflected, but the other colours are absorbed. This makes the object look yellow. We can also use transparent or translucent materials called filters to change the colour an object looks. These materials absorb some light but also let some light through to the other side of the filter. When a red filter is placed in front of a light source, it absorbs all the colours of light but lets red light through. This gives a red tint to everything you look at, and red objects appear even more red. If you have a light source and a green filter, the filter absorbs all the colours but lets green light pass through, making everything have a green tint, and green objects will look very green. These filters can be used in sunglasses, filtering out certain colours and also some ultraviolet light, reducing the harm that could be caused by the sun's rays. Photographers and filmmakers also use filters to change the mood and feel of their shots. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio.